Sometimes when you're trying to find the surface area of a figure, a three-dimensional figure, it becomes a little bit difficult. In my last video I showed how to break it into the 6 steps in the case of a rectangular prism. If we had a triangular prism, it would be 5 different sides. Another way to go about finding surface area is to actually make this two-dimensional. Since surface area in its essence is just area, we can think of it in 2 dimensions and be perfectly fine. So I'm going to take our 2 different 3-dimensional shapes and make them 2-dimensional, find the surface area that way. In this first case, we have ourselves a square prism. A square prism, better known as a cube. So we can take our cube and make a net of it, a 2-dimensional version of this shape. I'll start with the front face. That front face is a square. Notice I'm not going to draw it to scale here. If I take this front face and see what's attached to it, I can think maybe the top is attached to it. That's another square. We can also say, well, the front was attached to the top, but the front is also attached to the bottom. And that bottom is connected to the back. There's 4 of our sides. We still need the right and we still need the left. Now, the right and the left are actually connected to the front, the top, bottom, and the back. So really, I just need to place 1 square along the right. I need to place 1 square along the left. It doesn't really matter where. So this is a net for this cube here. It's the 2-dimensional representation of it. Since we're finding surface area, we just need to find the area of these 6 squares. We know that every square is 5 meters by 5 meters, meaning the area in each one of these is going to be 25 square meters. To do a simple calculation, do 25 times 6. And we find our surface area to be 150 square meters. Another way of doing this, just making it the 2-dimensional version. Let's take our triangular prism. The front face is a rectangle. We've got ourselves, let's see, let's add 1 dimension here. Let's say that it's a 3 by, you know what, I'm going to change this up again. Let's make it a 3 by 3. Right. So our front one is actually going to be a square, 3 meters by 3 meters. Right. That's attached to the top, which is actually a triangle. Oh, let's see. That's going to be something like this. This is also connected to the bottom, which is another triangle. And this front is connected to the back, which it looks like is going to be a 5 by 3. And that front is connected also to this side, which is going to be a 4 by 3. So we've got ourselves a net, a 2-dimensional representation of this 3-dimensional shape. Now we can find the surface area of it this way. We've got a rectangle, 3 by 5, well that gives us an area of 15. Got another base times height. This one's 3 by 3. That gives us 9. 3 by 4 gives us 12. Now I've got a couple triangles. Both of them have a base of 3 and a height of 4. Base times height divided by 2 is going to give us 6. Since they're the exact same thing, we know this is another 6. We can add all of these up. 6 and 6 and 12 makes 24. 24 and 15 makes 39. 39 plus another 9 gives us 48. 48 square meters to give us our final surface area of that